Welcome back. We have our basic gameplay implemented, and in this next video we're going to tackle aiming the character and also firing projectiles. So let's just see where we left off. If we hit play, you can see that we can move around the environment, but we can't really tell what orientation our player is facing. So right now I'm bumping around and changing the rotation of the player, as you can kind of see here. There we go. But there's no kind of indication on which direction the player is facing. So I want to add some geometry to our player here, just to be able to indicate and tell the player of the game which direction the character is facing. So let's use the same sort of parent-child relationship that we used on the environment. Let's create an object underneath the player, and we can do this by right-clicking on the player and choosing Create 3D Object. One of these simple primitive shapes will do. I'm going to choose a sphere. And the direction you move it will kind of matter because the player is facing a certain direction by default, so you want to move it out in front to show the forward-facing direction. And that's going to be along this blue z-axis. So moving it along here and up, you can kind of see it in the game view, so it's facing away from you currently in this view. And I'm going to drop it down to half its size, and I'm also just going to set the position to 0.5 on Y and 0.5 on Z. And so now if we hit play and move around, we can see, okay, when I bump into stuff and my character turns, then the avatar is turning as well. And it looks like our character is getting a little bit sideways, even though we have frozen the constraints. So I'm not sure quite why that is. One thing that we might want to do is remove the collider from this little nose that we just added, and that's just going to help us kind of not get caught on stuff as we traverse the environment. So I'm going to uncheck play mode and then click back on the sphere, and then for the sphere collider I'm just going to right click and do remove component. You don't have to do this, but it might make it just a little bit easier to navigate around. Okay, so we know which direction our player is facing. Let's go into the script and put in some code to orient the player. And for a twin stick game, what we kind of want to do is have it be based on either the right analog axis of like a game controller, but we don't have one of those. In a later video I'm going to show you how to set that up. What we could also do is have it be tied to the mouse movement. So as the player moves the mouse around the screen, the character could turn to face the mouse. This would be a more sophisticated form of aiming, and I'm going to cover that in a later video as well. But for this video, just to get through this basic kind of turning feature, and also to be able to implement some projectiles, what I'm going to do is just make it so that the character turns to face whichever direction they're going. So if you're in play mode and you press left, I want the character to face left. If you press down, to face down. Just basically point in the direction they're moving. So let's go into the player input script, load this up, and it's just going to be a simple single line of code that's going to do this for us. So down here below the movement, I'm going to hit return a couple times to add some space, and then I'm going to type in transform dot forward. So what this is saying is the transform, which is not capitalized here, this is accessing the transform component of this game object. It's kind of a shorthand way of doing get component. We could do get component and then pass in the type transform, but Unity figures, since every game object is going to have a transform, just store it as a local variable, and that's pretty handy. So transform.forward equals movement vector. And remember, the movement vector is our XYZ for the direction that the player is moving. Transform.forward is setting the forward direction of the character along or pointing in that same direction. So it's going to do exactly what I said, turn the character towards to face the direction that they're moving. Okay, transform.forward equals movement vector. Let's go back and hit play. And then we should be able to see that the character kind of moves around, looks around as they're moving, and kind of snaps between locations, and then when you release, it snaps forward again. And you also, if you notice, when you're not holding anything down, it says the look rotation viewing vector is 0. Well, those two things, yeah, we want to avoid this. We kind of want the player to face in the direction that they were last pressing, and also get rid of this warning, or this message. So to do this, we can go back into the code, and I'm going to put in an if statement. So we haven't done one of these yet, but an if statement basically is a true or false question. If it's true, it will perform the code inside of the if statement. If it's false, it will just skip over it or do an else. So type in lowercase if, and then open close parentheses. And what we can do to assess whether this movement vector is 0, and remember the warning said look rotation viewing vector is 0 when you weren't pressing anything down, and that's just because when you're not pressing anything down, these input axes are just returning 0. So when it gets to set this, movement vector is effectively 0. So what we want to do is we want to ask whether movement vector is not equal to vector3.0, and then do some curly braces to set up our if statement, and then we can copy and paste our movement vector transform code in there, and that's basically saying, hey, if this movement vector is not equal to vector3.0, then our transform.forward equals movement vector perform the look towards the direction. And let's save, and then go back to Unity, wait for it to compile, and then hit play. And now we have fixed both those errors. So no longer am I snapping back to that forward direction. It's stopping in the direction I was last pressing, and our little message here is gone. So we did a good job. Okay, so what's next? Well, twin stick shooter, we need some projectiles, some bullets. So in this next kind of sequence of steps, what I'm going to do is create some new projectiles objects. What we want to be able to do is kind of spawn those into the world dynamically, just whenever the player presses a button on the keyboard or clicks the mouse or something like that. Or potentially in the future, we want them to be able to be spawned in and fired by enemy units as well. So what we want to do is create kind of a reusable generic projectile. If we had to go in and create custom projectiles for every little piece of the game, it would get very messy. So we want to work in a very modular and create content in our game that's reusable. And what I'm going to show you how to do is use a feature in Unity called prefabs to do exactly this. So back when we were organizing our assets down here, we created a folder called prefabs. So prefabs are something that they're going to live in your assets, and what they effectively are is a kind of saved version of a game object or a kind of hierarchy of game objects that are in your scene. So just an example, I can turn any of these objects into prefabs and create kind of like a backup copy of them, which means that if I accidentally delete or modify them in the scene, I always have that master copy that I can revert to. So my player here, I could drag and drop this into my prefabs folder. Let's go inside there, and now inside prefabs I have this player. I can click on him and I can edit the same properties that I was accessing in the scene. And if you look in the scene, this player game object has now turned blue, whereas the other ones are gray. So a blue name and icon indicate that this is a prefab, so you can easily tell what's a prefab and what's not. And then if you look closely over in the inspector, you have some new properties as well. So before you just had the tag and layer and things like that. Now you have this prefab, these prefab options: open, select, and then overrides. So each of these do kind of different useful things when working with prefabs. The first one opens the prefab, and it opens it kind of in its own little scene where you can edit things about it. And then if you have autosave checked right here, those will automatically get saved back to the master copy of the prefab. Click the back arrow here to return to your scene. Select is going to select it in the project. This is kind of useful when you have a really complex project with a lot of content. You can easily find it and select it in the scene. And then lastly, overrides. So what overrides are is a way to manage what version of your player is kind of stored and saved in the project. So by creating a prefab of something, like I said, you're creating like a master saved version of that object. Now, I might want to use this player in a lot of different places. I might have 10 different levels, and each of them has their own player as part of the scene. That's just maybe how I've set up the game. But it can be a real nightmare when you have a situation like that, because if you had to create or maybe copy paste your player each time you were setting it up, that would be a lot of work and a lot of places to make mistakes. So what a prefab does is give you a way to save that master copy, but also kind of magically update it across the entire project. So whenever the player gets used in any scene, it will always use this master copy if the prefab, is connected, and it's a prefab, version of it. Now that's not always the case, and it's not always what you want. So let's say, for instance, in one scene, I wanted my player to have all the normal player behaviors, but to be able to move really slowly. I don't know, maybe this scene is like, it's got quicksand or something like that. Well, what I can do is I can select the player in that specific scene and come down to maybe movement speed here, and then change this. So I could plug in 30. And what that's done now is changed just this instance of the prefab. So here you can see Unity is kind of indicating that this is different because it's made this bold and the number here bold, and that means that this instance, the data in this portion of it, has been changed from the master. So if you click on the master and scroll down, this is still set to 50, and in our scene, obviously, this is set to 30. So this is, again, a really useful feature because sometimes you want a carbon copy of your master prefab, but you may want to tweak something. Maybe you want to change a material or turn on and off some functionality. This is how you would do that. Now, the last note about prefabs is the workflow of prefabs and using these overrides. So it's a common process to be in the scene, to be editing things. Maybe you're making adjustments to your player and you decide, hey, this 30 movement speed is actually pretty good. I want to push this change to the master prefab so that each of the levels get that same change. Well, I can do that with overrides. So I can click on my overrides here, and it's telling me, hey, you changed something. You changed something in the player input script. It doesn't tell you exactly what, but at least it tells you this has been changed. If you go ahead and add game objects or something, they'll pop up here as child objects and indicate that they're going to be added. And you have two options with overrides. You can either revert or you can apply. So if you've been editing something and you don't like how it's functioning, you want to revert it back to the master, click revert. If you want to push that change to the master and to any instance that hasn't edited that change, click apply. Okay, oops, I closed that down. But this just basically took the only changes that I made, speed, and pushed them up, and now those have turned back to a normal font, so I can tell, okay, this is now back in sync. And if I click on the player, I can go down and see that it's changed. Anytime I update the master copy, like I said, the instance will change. So I just put that back at 50 while I was clicked on the asset version, and my scene is now changed. So those are prefabs. Prefabs are super useful and important to know. There's no worse feeling when you get partway through game development and you've been copying and pasting and your organization has been really sloppy, and setting up levels or creating, gameplay scenarios just takes a lot of time and is really frustrating. If you're using prefabs, it becomes much easier to create content and create fun moments of gameplay and design your game. Okay, so we created a prefab for the player. Now, we don't really need a prefab for the player. Like I said, it's really useful because if we want multiple instances in different levels, we can just use this prefab. But there's another really good use for prefabs, and that is creating them out of objects that you want to, spawn into the world at runtime, so during gameplay. So this is exactly what we're going to do with our projectiles. We're going to create them and set them up for the first time inside of our sample scene, and then we're going to create a prefab of them, and then we can delete the version in the scene because we don't need that anymore. The prefab is all we care about. So let's go through this process. Okay, so I want to right-click in my hierarchy and choose 3D Object, and then I'm going to make my projectiles out of spheres, but you can choose to make them kind of out of whatever you want. I'm just going to move it off to the side just so I can see it. We're going to reset it back to the center of the stage in a minute, but for now I just want to be able to view it. And this feels a little bit too big for me for the projectiles, so I'm going to go down to, say, 0.35. You don't want something that's huge because obviously that would be hard to kind of avoid, but you also don't want something that's really tiny and you can't see. So I've set the scale up, and I have a sphere collider, which is going to be pretty useful, and I want to add a rigid body component. So I've already searched for it here, but go ahead and type in rigid body and then add a basic rigid body. Okay, so now what we have is, well, if we hit play, you can see what happens to our projectile. If it got spawned in, it would just kind of fall to the ground. That's not super great. So we definitely want to uncheck use gravity. And then we can adjust some of these properties. We might want to freeze the rotation and things like that in the future. But for now, let's just leave it kind of as it is. And then we can create a prefab of this and kind of go from there. Now, one thing we want to do is definitely rename this. So I'm going to rename this to projectile and create a prefab of it by clicking and dragging it into our prefabs folder. And here we have it. It went blue, so it's living in the scene still, and we don't need it in the scene because of course we're just going to generate these during gameplay. So I'm going to go ahead and delete it from the scene. Now, it's still in the project. I still have that master copy. And one thing that's you might want to do is take the position and just plug in zeros here. So it doesn't necessarily matter because we're going to be updating the position of this as it kind of gets fired and created, but kind of good practice just to keep things nice and clean. Okay, so we have our projectile and we have our player. And the functionality we want to create here is when the user presses some keyboard button or mouse button, we want to be able to generate, or instantiate is the Unity term for creating these in the environment. So basically we want to be able to do exactly what we're doing here. It's like drag and drop this projectile into the environment, and of course we want to do it pointing in a certain direction, located at a certain place. We'll get to that in a moment. But how do we tie these two things together? How do you tie a script, which is on a game object, to something inside your project? Well, we do the same thing we did with the speed and create a public variable, and then create a reference using that public variable. So let's go back into Visual Studio, back into the player input script, and underneath speed, let's add a couple lines and do public game object, capital G, capital O, projectile, and we can't set it equal to anything just yet because it's a game object. We don't want to initialize it with anything because we want it to be a reference that we set up. So we're just going to do public game object projectile. Make sure it goes green here to indicate this is the correct type. And let's go ahead and save that, and then go back into Unity. Now, what we need to do is create a reference here because we have our projectile, and we have our projectile kind of spot right here, and we have the game object. And this is a common thing in Unity, dragging and dropping things and connecting them together. It can be kind of tricky if you misclick, because if you click on your projectile, it's going to switch to the projectile and give you all the settings. So you want to make sure that you're selected on the player and you single click and hold so that you're moving this projectile around, and then move it over here, and it should turn blue when you drop it over that spot. So drop it there, and now you can see these are connected. You could click on this and it's going to select it in the project. Another way to do this is use that little target here and click on that, and you have two tabs. You have assets and scene, and scene is all the things obviously in your scene. Assets are things in your project, game objects that you can connect to. So you can choose it that way as well. But now we set up this reference, right? So this is not really a copy or anything of this. It's just a reference to the memory location that this projectile is going to be at. So what we still need to do is in the code implement the behavior that creates these when the user presses a button. So let's go back to Visual Studio, and down below our movement code, let's type in if, and what we want to do is another of our input, so capital I input dot get key down, and this is going to access the keyboard directly, and you do an open and close parentheses to call that function, and inside of that it's going to ask for a certain key code. So what is the key that we want to press down? Well, we want to do capital K key code dot space. So whenever the user presses the spacebar down, and remember this is get key down, so it's only going to return true that first frame that the user is pressing the key. It's going to perform some logic inside of the if statement. Well, what's our logic? What we want to do is instantiate. So type in capital I instantiate, open and close parentheses, and we can use the same variable that we've created up here and referenced in the inspector. We can copy this projectile and just paste it right in. Because it's a game object, it's going to know what it needs to do. So let's save this and see what happens when we get back into Unity. Okay, so let's hit play, and then let's move around a little bit and then hit space. And one appears, let's hit space again, and another one appears, and what's happening, it looks like it's shooting, and it kind of is, but what's happening is it's generating these in the normal place that they exist, which according to our projectile is at 0, 0, 0, and because it's got physics attached to it, it is bumping into this and firing it off straight up. So we can mash the space bar and you can see projectiles and clones of these projectiles are getting spawned into the world, and it looks like it's firing, but really it's just kind of using the physics system is pushing it away, and since it can't go down because there's a floor there, it's pushing it straight up. So that's kind of what's going on. Not really what we want. A couple things we need to fix, right? We need to be able to create this at a certain location, and we need to be able to send it on its path towards, whatever direction it was first facing. So let's go ahead and add that logic in. Okay, so jumping back over to our script, well, let's uncheck play mode first, just in case. Jumping back over to the script, what we can do, another version of this instantiate function allows you to do, is to give it a location in space and a rotation when it first gets created. So what we can do is click after the projectile keyword and put in a comma, and then you're going to get this little nifty little tooltip for what different versions of the function are accessible to you. So this is 2 out of 10. There are 10 different versions, and if you go down a couple, this one has the object, it has the vector3 position, and a quaternion for rotation. This is the one we want. But where do we want to put our projectile? Let's think about this. So if we give the location of the projectile to be the location of the player, then what's going to happen is the projectile is going to be created inside of the player and probably do that same physics thing of bumping the player around or doing something kind of unfortunate. So what we want to specify is instead a place where these projectiles will get created from. And the way we can do this is by creating a empty game object that is going to serve as a location and rotation in space in the game world that we can use as the position for the projectile creation. So let's click on our player here, and again, when we created the little nose here, we're going to right click on this root object, and instead we're going to do create empty. And empty game object, as we covered before, is just a transform. Doesn't have any other features. But we're going to call this one attack point. And this is going to be where our projectiles get created from. And because it's a child, it will move and rotate and position itself relative to the parent. So if we set it forward a little bit and we set it up a little bit, let's do 0.5 on the Y and 1 on the Z, then you can see that it's going to create those projectiles just straight in front of the character here. So that's pretty effective. It's kind of what we want. Now, when we were messing with prefabs before, we looked at overloading or overriding certain properties and pushing them up to the master copy. This is what is an indication here. This little plus is indicating that this game object is like a bold property in the inspector. It is not part of the master, so our master game player here does not contain this. So if we wanted to be a good practice with this, what we do is click on the player, go to our overrides, and then as you can see, okay, we've got our attack point. Let's apply that. Now, there's one more thing we need to do. We need to connect our player script to this game object. It's connected in a sort of physical way right now because it's a child of that object, but it's not created in a logical capacity. So there's going to have to be some way that we access that object from our script. And the way we do it is exactly the same as we did with the game object, the projectile. We can just do another public game object and call it attack point. And I actually have an error here, so if you put in a comma here to look at that function, just go ahead and delete that. What we need to do is, well, actually we can write the rest of this now. So take your attack point variable and put in that comma, and then put in attack point dot transform dot position. This is the position of the attack point game object using the transform, and then comma again and do attack point dot transform dot rotation. So that's taking the data that's associated with the transform of the attack point, and again, just using it as the location and rotation for the instantiation of the projectile. So that should be all good. You shouldn't have any errors with this, and you should be able to hit save. And then when we go to Unity, let me just demonstrate what happens if we run into a null reference, because this is common. Let me move around, and then I'm going to hit space, and red errors happen. Lots of red errors. The more I click, the more red shows up. This is an unsigned reference exception. So at certain points during game dev, you're going to run into null refs or unsigned reference exceptions, and it's going to be a common part of your game dev life. So how do we fix this? Well, this is just basically saying, hey, when we fire, something's going wrong. We can actually double click on this, and it's saying there's an unsigned reference exception somewhere in here. And that's because what we did, we created this variable, but we forgot to hook it up. So this is a blank, public game object. It's trying to create the projectile at the attack point, but the attack point currently doesn't exist. So what we need to do is connect the attack point down to the variable. So click and drag again, just like you did with the projectile, all the way down to attack point, or you can use the little target there if you prefer. And now if we hit play, we should be able to see it work. Okay, cool. So our projectiles still don't have any sort of behavior. They're just kind of bumping into each other, or the player's bumping into them, and they're moving around really slowly. You might want to adjust the mass of your projectile. So now we have a character that can move around and fire these projectiles, or at least create them. In the next video, what I'm going to do is add some logic to these projectiles to move them through the scene along a forward vector from where they get created. And then we're also going to dive into creating a very simple enemy that will follow the player around and fire projectiles.